So let's see if we can remember it. If you have a line, right, so this is sort of coordinate geometry speaking, right? Any line you like, let's just say its gradient is m. Now, I've just drawn this particular one, just as an example, going through the origin. So if its gradient is m, what's its equation? Y equals mx. Simple one, right? Okay, now, if I think about, what I'm after is this acute angle that's formed, well actually, not acute angle, the angle formed between this axis here, want to just grab a sheet? This axis here, the positive x-axis, and the line itself. So I'm interested in this angle, an angle of elevation, if you like. Okay. So how can I go about finding it? What we'll do is we'll take advantage of some of our really simple Year 9 right-angled tree and construct a right-angled triangle here. Okay. So what might be the most useful triangle to construct? Well, if we make a triangle starting from, say, that x-intercept there, right, and move forward 1 unit, okay? Now, I'm just going to zoom in and make my 1 unit really large so that you can see it clearly. So suppose that point there is 1. So this is going to be a triangle with base 1, okay? Now, if I construct my right-angled triangle here, okay, because that's a straight vertical line going up, the coordinate of that point will be, well, the x-coordinate will be 1, and when you sub 1 in to this, your y value will be m. And that simply means that corresponds to the fact that gradient is rise over run, right? M over 1. So if this base down here is 1, and because the y-coordinate's m, that means that vertical height is m, okay? Remember what we were after was theta, so this is where that familiar result comes out from, right? Tan theta is opposite on adjacent. Okay, so you often see it written in reverse. Morning, grab a sheet. N equals tan theta. Okay, so that's simple stuff. Now, by the way, I put this line just because of it was convenient. I put it through the origin. What would happen if I had, you know, suppose it was x plus b, and it was like moved up or moved sideways or something like that? What difference would it make? Answer, no difference at all, right? Having a vertical or a horizontal shift, morning, grab a sheet before you take a seat. Did it finish? It finished, didn't it? Okay, great, you're actually good. Anywhere. Morning, grab a sheet. What was I saying? Having a vertical or horizontal shift doesn't change this at all, okay? Because these distances and that angle will still relate to each other in exactly the same way. Sorry. Alright, so let's take that, draw another diagram beneath this, and let's shift it to an angle between two lines, which is what we're really interested in. Now, when you're looking at these two lines, right, so I should put some extra things on my axes. Generally what they're looking for is the acute angle. In fact, the question will usually be phrased, find the acute angle between these two lines. Okay, occasionally they'll want the obtuse angle, but I'll show you how to get that later on. It's actually quite simple. Okay, but in this case, the acute angle I'm after, the theta, right, is in between here. And you can probably see, like, that angle is vertically opposite this angle, so those are the same. It doesn't matter which one. The acute angle is only one of them. Okay, it's the same in both cases. Now, how can I relate this to that, right? Well, this angle is related to this angle for each line, okay? So since I've called it theta for that angle between two lines, let's call the other angles different names. So for instance, if that's alpha, there in the corner, and that's beta, okay? So we know how to work out each of these lines if we know the gradients of the lines that they correspond to, okay? So suppose this line here, the one with an angle alpha, so suppose it had a gradient m1, okay? And you can see I put them at different intercepts, so I really should say plus, say b1, that'll be its y-intercept. And let's call the other line's gradient m2. And of course, it has a different y-intercept that corresponds to wherever it hits. Okay. So, how do I get theta in terms of alpha and beta? Well, what's the most direct way that relates those? The thing. That's exactly right. I'm so glad we're on the ball this morning. The thing, if what you mean is the exterior angle of a triangle, then that is the right thing. So what you're going to have here, right, beta, the exterior angle of this triangle, okay, beta is equal to theta plus alpha. Is that okay? And I might as well say exterior angle. I really should say it equals the sum of the opposite two interior angles, but I think you get what it's talking about. Okay? So therefore, in this case, right, theta is actually equal to beta minus alpha. Okay? Alright, now how can I get from here, or rather from here, to something meaningful out of this, right? Well, relating the angle and the gradient requires that tan ratio, right? So I'm going to take tan of both sides. Move over a little bit. So tan theta is tan of beta minus alpha. Okay, but you guys know the expansion for this, so we can actually break this out. Beta minus alpha. So which one's going to be the plus and which one's going to be the minus? The top will be the minus. Okay, so this is going to be tan beta minus tan alpha, right? And on the bottom, because that was the minus, this will be the plus. Okay, so 1 plus tan beta tan alpha. Okay? Now, the great thing about this, the reason why this is actually useful and not that gross, is because I know what tan alpha and tan beta are in terms of these gradients. Okay? So because alpha is here, I can say tan alpha is that gradient. Okay? You can see how it's really just follows out of that. And tan beta is the other gradient. Okay? So if I just do a substitution in here, what I've got is m2 minus m1 over 1 plus m2 m1. Or, if I swap this around, okay, I would write it as m1 minus m2, 1 plus m1, m2. Okay, now, that's the result, okay? Tan theta, that is the angle between the two lines. Morning, grab a sheet before you sit down. That's the result. Now, before we start using it, okay, I want to address the question, how do you know which one to put first? Is it this one? Or is it this one? Now, I want to let that question sit in your mind for a second. Which one do I use? Which gradient do I put first? And let's have a look at an example question, okay? And hopefully the example will answer which one do you put first. Okay?